Hello guys, welcome once more to another video on our YouTube channel. So in this video we are going to be solving a question from the West Regional Mock Examination of 2024 Physics Paper 2. This question was on optics and the question reads: we have a diagram displayed to us, and this diagram explains how a ray of light is leaving from air. It is incident on the surface of glass at an angle of 44 degrees with the surface of glass. Then once it enters into the glass medium, it is being refracted, and then it now enters the surface of water at an angle of lambda with the normal. Now when it enters water, it is being deviated or refracted, bent again, and the angle between the final ray of light and the normal is theta. Now question A: given that the refractive index of air, glass and water are respectively 1.00, 1.50 and 1.33, determine the values of the angles lambda and theta. Question B: determine the range of values for lambda for which the ray of light entering water from glass will completely turn back into glass. Question C: state one application of the phenomenon in B above. So this is a question on optics, and I will like us to analyze the problem together. If you're just joining us in this channel, make sure you subscribe to the channel, you like the video after watching, and you also comment. Okay, so the first part of the equation, we need to determine the values of the angles lambda and theta. So let's start by analyzing the air to glass relationship. So we are going to use Snell's law, and Snell's law says that the refractive index of the medium times the sine of the angle of incidence is equal to the refractive index of the next medium times the sine of the angle of refraction in that next medium. So we are going to have that the refractive index of air times the sine of the angle of incidence, since it was moving from air to glass, is equal to the refractive index of glass times the sine of the angle of refraction in glass. Now from here you realize that since the refractive index of air was given as 1, we just have that the sine of the angle of incidence in air is basically the angle of incidence is the angle made by the incident ray and the normal. Since the angle made by the incident ray and the surface of glass is 44 degrees, it therefore means that the angle made by the incident ray and the normal is 90 minus 44 degrees, because the angle that the normal makes with the surface of glass is 90 degrees. So to get theta I, we need to take 90 minus 44 degrees. Doing that, we get 46 degrees. Now the refractive index of glass is 1.5. Then the angle theta arrow is the angle of refraction in glass. Refraction is the bending of light as it moves from one medium to another. Alright, so from here you realize that the sine of theta arrow is equal to sine 46 divided by 1.5, which will approximate to 0.48. So theta arrow is sine inverse of 0.48, which if I want to give it to one decimal place, I'm going to get 29 degrees. But you realize that theta arrow and lambda are the same angles because they are corresponding or alternate angles. Okay, so this angle here is equal to this angle because the two surfaces, the surface of glass and the surface of water, are parallel. So theta arrow is equal to lambda. So since theta arrow is equal to lambda, it therefore means that our lambda is 29 degrees. Now let us analyze the glass to water relationship. So we are still going to use Snell's law, and in this time around the incident ray becomes the refracted ray. That is, the refracted ray when it concerns the air to glass medium, the air to glass relationship becomes the incident ray when it concerns the glass to water relationship, while the refracted ray in the glass to water relationship is just this ray. Okay, so applying Snell's law, we see have that the refractive index of glass times the sine of the angle of incidence. This angle of incidence is basically lambda, alright, equal to the refractive index of water times the sine of the angle of refraction, which is theta, the angle that the refracted ray makes with the normal. Alright, so from here you realize that 1.5, the sine of 29 degrees, is equal to 1.33, the sine of theta. So I'll divide both sides by 1.33, and then when you simplify, you're going to have an approximate value of 0.55. So if the sine of theta is approximately 0.55, then theta is approximately sine inverse of 0.55, which will approximate to 1 decimal place as 33 degrees. So it therefore means that lambda is 29 degrees and theta is 33 degrees. Okay, now the second part of the equation. Determine the range of values for lambda for which the ray of light entering water from glass will completely turn back into glass. So coming to the diagram, what happens is that this ray of light that is entering from glass to water, or entering water from glass, has to completely turn back into glass. So this is what they are talking about. So we need to find the range of values of lambda for which this ray of light will rather be this ray of light. Alright, so basically this is what we call total internal reflection. Total internal reflection occurs, first of all, according to the situation. This is not refraction again, it is now reflection. We are now reflecting this incident ray to have a reflected ray still in glass, because reflection is the bouncing back of light as it meets a surface, a smooth surface. So when this happens, okay, then we are talking about total internal reflection. We are not just talking about reflection, because glass does not reflect light. It's a plane mirror that reflects light. Glass rather refracts light, as well as even water also refracts light. It bends light. So if the ray of light is being if the ray of light turns back completely into glass, then that condition is total internal reflection. Now let us give the conditions for total internal reflection to occur. Firstly, we have that the angle of incidence in the more dense medium must be greater than the critical angle. The more dense medium is glass because it has a refractive index of 1.55, and the less dense medium is water because it has a refractive index of 1.33. The refractive index of glass is more than the refractive index of water, so glass is a more dense medium. So for total internal reflection to occur, the angle of incidence in the more dense medium, which in this case it is lambda, must be greater than the critical angle. But anyways, we are going to talk about the critical angle later. Now this is a first condition, but for this total internal reflection to also occur, then we also need that the light must be moving from a more dense medium to a less dense medium. So moving from glass to water, from more dense medium to less dense medium, then the total internal reflection is going to occur. And when it occurs, then the angle of incidence in a more dense medium will be greater than the critical angle. Now, what is a critical angle? The critical angle is defined as the angle of incidence in a more dense medium that will produce an angle of refraction in the less dense medium of 90 degrees. Which means that if we have this, and then this is my normal, we have the this is glass, okay, this is the incident ray, right? Now once the angle of refraction, if you look at this ray, okay, this is the angle of refraction here is theta. If the angle of refraction is 90 degrees, that is the angle made with the normal. It therefore means that this line here is going to be purely horizontal. So when the ray of light is incident on the bottom surface of glass, okay, and we have a situation such that the angle of refraction is 90 degrees, then the critical angle is the angle of incidence in that situation. So the critical angle is the angle of incidence in a more dense medium that will produce an angle of refraction in a less dense medium of 90 degrees. So this angle arrow here is the angle of refraction, the angle that the refracted ray makes with the normal. You see, the refracted ray is horizontal and the normal is vertical, so the angle between them is 90 degrees. We can see that the two are perpendicular. So again, the critical angle is the angle of incidence in a more dense medium that will produce an angle of refraction of 90 degrees in the less dense medium. So if we still analyze using Snell's law, you realize that n glass sine C will be equal to n water sine 90. Sine 90 is 1. So we just have n glass sine C, because C is the angle of incidence, which is the critical angle. And replacing the angle of incidence with the critical angle, then our angle of refraction will be replaced with 90 degrees. Since the sine of 90 degrees is 1, then we just have that the refractive index of glass is equal to the refractive index of glass times sine of the angle of incidence, which is the critical angle, is equal to the refractive index of water. So it means that the sine of the angle of incidence, which is the sine of the critical angle, is equal to 1.33 divided by 1.5. So you realize that your critical angle to 1 decimal place will just be sine inverse of this value, which will give you 62 degrees. Now for total internal reflection to occur, the angle of incidence in the more dense medium should be greater than the critical angle. What is the angle of incidence in a more dense medium? It is lambda. Okay, back to the equation. The more dense medium is glass. So since we have found the critical angle and the angle of incidence in a more dense medium is lambda, then total internal reflection will occur when lambda is greater than the critical angle. So the range of values of lambda is lambda strictly greater than 62 degrees. And definitely, your lambda is also supposed to be less than 90 degrees. So you are greater than 62 degrees, but you are less than 90 degrees. Okay, so you have to add that condition. Lambda is between 62 degrees and 90 degrees. The last part of the equation was asking us to give the application of total of the phenomenon in question B above. So the phenomenon we have realized is total internal reflection. So I'm waiting for your comments in the comment section telling me 1 or 2 applications of total internal reflection. Thank you guys for watching. If you enjoyed the video, don't forget to give us a like, subscribe to the channel, share the video with your friends, and again, your comments. See you guys in the next video.